French and the SML. Okay, it's all there. This is something you'll need to set up for the project. Okay, you'll need to set it up, however, for 10 securities. Okay, with different benchmarks. Okay. So I'm going to take you through what it is you need to do. This is the information, right, that you need for all the securities and such, right? Common friend, you have the RF for this three rate. So I'll go back. Let's go back to the securities. Okay. First thing that I suggest you do is a correlation test. Now, why do I suggest that? Because you may want, but don't necessarily need, a diversified portfolio. How are you going to build a diversified portfolio without knowing the correlations between the securities? Well, you could do this. Right? So that may be useless. So as a consequence, you do the correlation test. Okay. So there's the correlation test. There's the result. Okay. They're all pretty heavily correlated with each other, right? And the data that you're going to see, and I will help you with that, the data that I send you, which has all the returns and necessary benchmarks, right, will have the correlation table in it. Okay. You basically trade this off as to whether or not you want to diversify things. Okay? Now, where is this coming from? I haven't showed you how to do this scan Excel stat. So let me go back to the data. Vote Excel stat. Okay. And this is fairly simple, right? There's no magic to this one. Okay. You go to correlation association test. Hopefully everybody sees that. Go to the drop down, and then you go to correlation tests. Okay. Click on that. As usual, you can grab more than one vector, set of random variables. Okay. Outputs. Do these outputs. Descriptive stats, correlations, and p-values. Basically, they're the default ones. Okay. But just make sure that you have them. Okay. And click OK. This is the table that you get. What do the blacked out numbers mean? That means that they are significant correlations. Okay. You can get correlation numbers, right, and they can be insignificant, which basically means is that there's no correlation whatsoever. Okay? So that's pretty much what we're talking about here. They're all correlated with each other, so they wouldn't necessarily give you a lot of diversification. All right? So that's something that you need to keep in mind, right? So you'll be given basically 10 securities. They are all portfolios. They're all ETFs, so they're all index products, right? So everything should work a lot better than individual securities. This is why I do ETFs, okay? Because everything that we saw so far, right, is that things work a lot better for portfolios than individual securities, right? Things can kind of go sort of loopy, if not down. Individual securities, right? So these are mutual funds, okay? So their correlations are fairly heavy. And again, they're bold, which means is that they are significant, right? If you see numbers, even if they're not zero, right, but they're not bolded, then basically there is no correlation there. Okay, just keep this in mind in terms of the interpretation for the correlation table. Actually, what I may do, if there's time, I'll actually show you the data, and you'll see what I mean by that. Actually, maybe I'll just do that now. Go. So there are all the securities, okay? So you have U.S., you have non-U.S. stocks, you have U.S. bonds, okay? You have U.S. stocks, you have 2 commodities, you have 10 ETFs in total. Notice is that some of these, right, that says is that that's a negative. Yeah, but it's not bolded. So what does it mean? 0. Don't be misled by negative numbers if it's not bolded. Okay. Yeah.
So if my goal is to maximize diversification, then you want to select the
Non-bolded. That's right. You're asking that question. Yes. Right. Or, right, if it's still bold, right, you can take a fairly low number if you don't mind doing that. Because ideally, right, you would want to actually choose the non-bolded numbers, right? Notice is that most of the negative ones I'm looking at are fairly, here's one. Okay, the U.S. bond free, the U.S. stock free is very nicely anti-correlated, negatively correlated, okay? It's the reason why I chose these securities, because, they make you think through a lot of stuff, right? How do you do diversification, right? You try to take uncorrelated entities, but maybe you don't like the returns on some of these. Maybe the Sharpe ratio for this U.S. bond free is pretty shitty versus this one. Right, now what? Right? Do you trade off diversification and for return, for risk-adjusted return? Your choice. Right? This is all part of the gig. Right? If you were an equity analyst, right, and I was the portfolio manager, I would expect you to be explaining this to me. Yes, it was negative correlation, and that's good, but I didn't choose it because the Sharpe ratio was bad, or Trainer wasn't good, right, or something of that sort. Okay. And notice is that, and I'll give you the information, right, is that you'll be able to do, I think, pretty much all of the performance measures, right? Sharpe, Trainer, all of the others using the ETFs and the appropriate benchmark. Okay, so you'll be able to do all those calculations, right? You'll have the risk-free rate. Let me drop this down a bit. There's Trainer. Okay, you'll be able to compute the data. You'll be able to do Jensen. You'll be able to do the M2 measure, and if you want to, you can do Sortino. I actually did a little bit of Excel programming. I have to admit, I cheated. I went onto a website, and there's an array competition, if you know what arrays are in Excel. It's basically how to work with vectors. And in the, over here, which you don't see, it's the other spreadsheet. I pasted in the formula in case you want to do it. All right. So I'm showing you this just so as you can see that not all the numbers mean something in that are they other than 0. 0, 0, 0, 0, right? Another 0. Zeros except for that one. Right? So not significant, no correlation. Okay. All right. Let me go back to the original document. And again, just to show it to you, correlation association tests, okay, and there's the data. Now I'm giving it to you initially, okay? In the follow-up piece, meaning also part of the project, we will have to run this correlation test more than likely. Okay. So after you've done correlation tests, right, we all know is that there are some issues with normality, right? If I go back up, right? We have Sharpe, and if there's skew and/or kurtosis, right? We'll use the adjusted Sharpe. Okay, we should get that into account, all right? And you also may want to use Sortino. Why? It accommodates non-symmetric events. Okay. So let's go back up. Now, here are the normality tests. Okay. And what you'll see is that only the first one, right? You know, I'll go up to the top. Okay. And what you'll see is that only this one has a significant JB result. Okay. You know, as it says down there, right? Try to get that back so it doesn't just jump on. There we go. Okay. says reject, okay? The other two, it says accept. So this is one where you would probably, at a minimum, want to use sharp, okay? Because there may be some distortion in the other one, okay? Okay. So far we've done correlation tests, and we did those because we may be wanting to, you don't have to drive to diversification. It's not a need to or must. It's a decision on your part, because what you may see is that there are all these really nice Sharpe ratios out there, right? Or things of that sort, right? And you find out that they're all correlated in some way, shape, or form. So that's okay. I'll throw the dice and I'll see what happens, right? Because this is the portfolio that I want. There's no such thing as an ideal portfolio in this case, right? I'm not judging you as to how close you've come to an ideal. Okay, that's not the case. Not in the least, right? This is where the whole thing about understanding and insight, and my favorite word, rigor, is important. Okay. Next one. So if you have a JB test, which is significant, right? And you want to do descriptive stats, and why do you want to do those? Because you need them for the adjusted chart, right? Tau is skew, kappa is kurtosis, right? Lambda is the Sharpe ratio, right? It's all on the slide. I'm guessing short-circuited it up above. Okay. So you have for that very first security, this is, you can put that in, but that's not significant, right? So those are the values you would put in, okay? The Sharpe error says that it's, that it's not normal. Run this test, pick up the coefficients, regardless of what you may think of them. Right, significant, not significant, because like what we don't know from Sharpe is it skew or kurtosis or both. Okay, that's why you would do this test. Okay. Now we know, right, that at least for trainer, if not someplace else in the universe of performance measures, right, that you need beta. We're also going to need R squared as well, because R squared is the mother diversity factor, right, for any portfolio, right? You start from there, okay? So now, how do we get betas? They actually come in a few different flavors, but basically, the beta that I want you to use, right, is basically the market or the benchmark, okay, against the security. It's the old characteristic line phenomenon, right? The very first regression approach, okay, which was basically the regressor, right, was the market. In some cases, you'll have to use a benchmark instead, okay? And the dependent variable is the security, right? This is where the beta comes from, and it's where R squared comes from, okay? And what you'll see is that this one security, right, from an R squared standpoint, isn't terribly well diversified. Right? So that means that if you chose this security, and as it turns out, I think this security has the best, by far, Sharpe ratio, right? You may want to be adding to it, right, to make it, let's say, make the portfolio, I should say, more diverse. Right? Taking away more of the micro, idiosyncratic, unsystematic risk. Okay, but again, that's a choice. Right? You need to be clear to me why you're making this choice. Okay. Again, there's no such thing as an ideal construction here. No, doesn't exist. Right? It's all up to you to decide. Okay. So when you do betas, right, and again, the betas come from basically running the analysis, right? I'll just do this one in case things are a little foggy. You go modeling data, linear regression, okay? You got the Y variables, okay? pick up the X variable, I'll just move this out of the way, it's the market return for the appropriate benchmark. Okay. And say okay. And there you have it. Okay. So there's the regression piece. Okay. You're regressing the market in this case on the security. In other cases, you'll be regressing a benchmark. If questions should come up, by all means, get hold of it. Okay. I don't want to obfuscate this simply because you've forgotten that, oh, in this case, I need to use the market. And when do I use the benchmark? I'll tell you that, right? It's not a big deal. Right? That's just mechanics, right? If you're having problems with mechanics, reach out to me. Do not reach out to me if you want me to interpret something for you. That is not hopefully, the homework, that chapter 22 homework was very important, right? Because, it really made you think about this stuff, right? And I don't just mean the questions. The questions were rather challenging in some ways, right? But the problems in computational problems, right, you really had to have a fairly significant understanding of the performance measures for things to actually work out. And as a matter of fact, I gave almost everybody 100 because you were all kind of close, right? I didn't want to necessarily, I almost said bash your ego. I didn't want to necessarily discourage you prior to the project, right? But it's like one of those things, right? What I'm really looking for, right, is something that sort of goes along the lines of the chapter 22 homework. Right? That would be very helpful, right? For me, and more so for you, okay? Okay. And you may remember is that to do some of that homework, you actually had to do regression so you could get betas and you could get R-squares. Okay. All right. So the next thing is Jensen's alpha, okay? Which is another regression routine. Let me bring it down. Here's Jensen's. And this is used to judge manager effectiveness, okay? Will you necessarily be doing this for the securities I gave you? No. They're index products, okay? There's nobody actively managing them. So I would suggest not doing Jensen's unless you want to do it for laughs. Okay, I understood you explained a way of saying that. Okay, so there's Jensen's. I simply set it up for you. Why does this one work? Because these are managed portfolios. They're actively managed portfolios. Okay. So what we have here, right, is that you may see, right, is that basically what you need, right, is the performance of the portfolio less the risk-free rate. Okay, that's one input. Then you also need, right, the market minus the risk-free rate. Okay, right, and then you have the data. Okay, so now you should be all set, right, because this is a regression equation. Okay. And you're going to find out, is this significant or not? Okay. So I'm just going to take you through this, though more than likely you won't be doing it. All right. I'm simply showing you if you have an actively managed portfolio, then you would do Jensen's. All right. So there's the regression. So let's just do an actual example here. It's modeling data, linear regression. Grab the data, right? Same data. Okay. Oh, what we want in skip. Actually, no, it's different. That's right. This is Jensen. Okay. So we grab this data instead, right? And the quantitative, right? It's not that, but over here. Where did it go? That is I didn't put this in. I must have erased it at some point. But basically what you would do, and maybe what I'll do is I'll do it now. I'll insert a column. Take that down. linear regression. Data. So here's common French, right? Market minus risk-free. Run it. And there's the results right there, right? This is another regression equation, right? And it has two inputs that you need, right? The portfolio minus the risk-free, right? And then this minus the risk-free. You know, why would you be subtracting the risk-free? Well, it's because sometimes this can be compounded, right, by other variables, you know, such as the risk-free rate itself, right? So as a consequence, right, to try to eliminate that kind of confounding, you take the risk-free away from the portfolio, you take the risk-free away from the market or the appropriate benchmark, okay? Hopefully what that does is that eliminates some of the confounding that's going to be in the intercept. Okay. So there's Jensen's alpha. Okay. And you'll see is that there's Jensen's alpha. And you'll see is that there are no significant alphas, though that one's kind of close, huh? 1.9, right? And a 0.71 for the intercept for the alpha number, but it still doesn't quite cut the mustard. This one doesn't either. And clearly that one doesn't. So in all cases, none of the managers are adding anything to the running of the portfolio in terms of alpha. Okay. Now that doesn't mean that they're doing a bad job. Okay. What it actually means is the following, right? They may be good at doing factor tilts like growth and value or size or something of that sort. Right? That's not going to get captured here. This is the reason why you would do the next one, which is Fama French. Okay. And the Fama French equation that I want you to use, right? That's right there. Okay. Once again, you take away the risk-free rate from the security. You also take it away from the market. You will not be able to do this for bonds and non-U.S. stocks and commodities. This only works on U.S. stocks. Okay. You need this. You need small minus big and high minus low, right? The size factor and the growth and value factors, the value premium factor. Okay. And then what you'll need to do is to again run that regression, right? Only now you have a multiple regression, okay? And then here's the table, right? I'm going to summarize all of these results on another page, okay? And what you'll see is that you have two significant t-stats here, right? One on the HML and one on the market piece, okay? Everything else is not significant. Now, the HML is positive, right? That means it's a tilt towards value versus growth.
Yeah. How do you tell if that T is significant?
Oh, it's going to be 2 or greater.
Yeah.
Right. Or it's the absolute value of T. Because like you can come up with negative values. So take the absolute value. And if it's 2 or greater, then it's significant. Okay? So it's positive for the HML, right? As it's positive for the HML, that means there's a tilt towards value, meaning there's an emphasis, consciously or not, on the manager's part to be a value fund, okay? Is that a value? Yes, it's a value. I'm wondering how many more times I can use the word value without stopping. I'll stop now, okay? No, there's a value premium. You know, is that value, am I up to 10 yet? Yeah, okay, thank you. Then there is a premium, right, with those stocks that have high book to market numbers, That's the tilt, okay? If it was a negative number and significant, then the tilt is towards growth. Okay? That's all high minus low minus. Positive value, negative growth. If it's not significant, then it's not tilted either way, right? Which is fine. Right? You would do something that's called blend or core. It goes by two different names, right? They both mean pretty much the same thing. Okay? If I go down some more, okay. Here's the next one. And what you'll see here is that the only one that's significant is the market. So there's no tilt in terms of size and no tilt in terms of growth versus value, right? None of them are near 2. Now, notice is that, as I said when I answered the question about how do you know what value, right? There can be negative t's. That's perfectly fine. Right? You just take the absolute value. That's it. Absolute value equal to or greater than 2 and it's significant. Yeah. How do you do the beta here?
Yeah.
Well, you do the regression. Yeah. Shall I run that up? Yeah. Not a problem. So same thing as before, only this is a multiple regression. So we do this linear regression, okay? Then we grab this data, right? Because look at the formula, right? It's the security minus the risk-free. Okay. What are the factors? They're the common French factors which I've supplied you, right there. Okay. And that's basically all you do. Okay. Just make sure that you grab the right variables, right? That's why I'm saying when you set up the worksheet, right, you're going to have to, let's say go back to this formula, right? And you're going to have to set this up. If you're going to do Sortino, you'll need something, right? I'm supplying you with these values, right? Actually, this one is in the common French groups, right there. Okay. And it'll be marked for you. Okay. So that's all it is. It's just another regression which gets done. So there are a lot of regressions going on here, right? There are the normality tests and such. Right? So what I'm going to do now, just so as everybody can hopefully see this, is that I'm going to insert some columns and try to center that a bit. Okay. So here's everything mapped into one worksheet, okay? Everything is now there. So what you'll see is that there's the sharp for MQIFX, right? You'll see is that it's bigger by a lot than the other two, okay? How is it calculated? There's a formula in that cell, that formula right there, okay? And basically, you have to keep in mind, and I'll go back up to sharp, is that because you're dealing with time series data, right? Numbers like this are an average over the horizon. Okay? Do not do it period by period. Okay? You do the whole thing using an average. Almost all of these things in terms of the ratios use an average. And basically what you'll see here, right, is that this is the average of something called F2 to F82. So I'll go back. Okay. So what is F2? Actually, what's in F? Right there. Okay. The return minus the risk-free, which is exactly what you need for sharp. Okay. This worksheet is in Excel, right? It's in Canvas, right? So you can pull it up and take a look. You'll see all the formulas in case if you forget how to actually do the performance analysis. So let's just go down this first one, okay? We got Sharp, right, that's trainer, okay? The formula is in there for trainer, right? It's another average piece, but now you're grabbing the beta, right? That you calculated right here. Okay? So we have the average, we'll bring trainer, it's here, right, of the portfolio minus the risk-free rate divided by the beta. In the beta, exclamation part, 42, what is that? It's the beta for that security. This is another reason, the main reason why you do all of this work, right, is that to come up with the performance measures, you need to do regressions for the most part. Okay. So let's go back. Okay. Jensen's alpha, I simply put in 0. I didn't want to confuse anybody by putting in a value that's anything other than 0, right? Because none of those, right, if we go back to Jensen, okay, were significant, right? That one was the closest. But that was about it, okay? And again, I would suggest not doing Jensen's, unless you want to do it for some strange form of practice. Right? We don't need to, simply because Jensen's is manager effectiveness and we're doing the index products. Okay? So it's not needed. M2. So let me go down to M2. Similar to Sharp, only it uses a benchmark. This one you'll be able to use for the other securities, okay? If you want to. You won't be able to use trainers necessarily, but you will be able to use Sharp, okay? So we need the risk-free, we need the standard deviation for the benchmark, standard deviation for the portfolio, and then the risk premium, right, for the portfolio itself. It's return minus the risk-free rate, right? So it looks sort of similar to Sharp. So the formula is in there. It's a somewhat more complicated formula, but I can show you the pieces, okay? Here are the pieces, right? Once again, we're dealing with averages over the horizon, okay? So how do you get the risk-free, the very first element, right? You average all of these. Okay. How do you get the standard deviation for the benchmark or the market? And it's right there. Okay. Just compute the standard deviation of that. How do you get the standard deviation for the portfolio? And remember, it's the portfolio minus the risk-free rate. That's it right there. So that's why it's important to set up that first worksheet really well, right? Because you're going to need a lot of input to do all of the regressions and then the performance measures, okay? Okay. I did the information ratio. Actually, I was thinking about it today, trying to show you how odd my mind is that I actually will think about these things outside of class, right? And it is that this information ratio was first developed when, I'm trying to think of the fellow's name, but he actually came up with this measure called active return, right? And it's a factor model, but it includes a rather interesting factor called information coefficient, which is actually a proxy for manager skill, okay? So that's what the active return is, right? It's not the manager skill based upon alpha. It's a very different looking model. It is a multi-factor model like Palma French or APT, right? But it's different. And I realized that that was one of the reasons I never liked the use of the information ratio as used by folks like Morningstar and others, right? It's in so many words a bastardization of a good tool, right? So, but that's okay. I mean, I showed it to you again because it's in the book. Don't use it. Okay, don't use it. You know, I had to show it to you. If somebody ever asked you, do you know what the information ratio? Yeah, it is. Yes, it measures risk and return. That's helpful. Hopefully that's all it's on. What's your opinion of it? You can quote me. My instructor said, and they may say, great, yeah. And they may say, what the, what's he talking about? Okay. Now here are the R squareds, okay? Also coming from the betas page, right? Beta, okay. This is the major tool to determine if the security, in your case, the index product is itself already diversified. Okay. Big thing, right? Assuming you're after a diversified portfolio, right? Some combination of ETFs, right? That will give you diversified. Again, you don't have to do that. You may want to say, I'm fine with it. I would rather try to capture one of the from French choice, right? So as a consequence, right, I'd rather have that than anything else, right? So that's a possibility. I did Sp19 in case anybody was interested, right? If you want to do it, fine. If you don't want to do it, that's fine too. The formulas are here, right? There's the array formula, and there's the actual final calculation, okay? I also did the adjustment for sharp, right? I have the whole formula in there, right? There's the skew value, right? Comes from the description page, the descriptive stats page. That comes from it as well. There's the kurtosis, and there's the actual calculation, okay? Not, these two don't change because they didn't have significant skew or kurtosis, okay? So this way you can line it up. Does it tell a different story? No. Does that tell you is that the skew and kurtosis were large enough that it should affect the sharp? No. But you just may want to do it, you know, just in case you see something like that. Now comes a rather interesting phenomenon. This is the famous Fama French. Okay? This is the summary. Okay? So for that first security, right, it has a tilt towards value. And of course it has a tilt towards the market. All of them do. Okay? The last one, TRSSX, right, is tilted both towards value and size, meaning small caps. Okay, that's perfectly fine, right? Of course, market is significant as well. Okay, no intercept is significant. Okay, this is the time for you to decide whether or not you want to do value versus growth. Right, that's entirely possible. But it may be nice as if you gave it a shot. The reason being is that next project, you will get points for how well you did against everybody else. Okay, I'm not going to do it next time. It's not production for investment. So as a consequence, if you want to try that, that's fine. Or just experiment with this, you know, and just find out what you like. You know, again, you have commodities and bonds as well. Okay. So what you do, right? I'll just go back. Let's go to the very beginning, right? You have to set up all the necessary supplemental data that you need. You're going to get this, okay? You will have to do all of these, okay? All of them, right? You'll be given returns. You have to calculate this, right? Because you needed to do some of the regressions, okay? This you will have. You'll need to compute this, right? Because you need that for some of the regressions and also the performance measures as well. And off to the side, right? Here's all from the French, and there are the SMLs. Okay. So if I go back to the actual project itself, and I'll show you the data. This is small. Apologize for it. Okay. But there's all the securities. all 10 of them. And they're noted for you just so as you can see what kind of ETFs they are. Okay. There's the market. I'm proxying it using the SPY ETF. There's Fama French. Okay. And then here are the benchmarks, because chances are, right, as when I show you the project, I'm asking for a minimum of 5 securities, right? You're going to be melding, combining different kinds of securities. Okay, so to do some of these calculations, you need benchmarks other than the market. Okay, you may. But it'll be up to you to decide where and when these sorts of benchmarks should be used. Okay. So let me take this down. Okay. And I'll simply minimize this. Okay. And now what I'm going to do, okay, and I'll do it on both sides just so as everybody can see it. And this is also in Canvas. This is the project. Okay. I'll take you through it. This project is about how securities can be chosen using such things as risk and return. Storyline. The storyline, though I know you know. You are the portfolio analyst, and I am the portfolio manager. I have given you a list of 10 securities to evaluate and make recommendations on. Tell me which securities to buy. Okay. After the securities are chosen, you will assemble and run an equally weighted portfolio on the chosen securities. Okay. Then you will evaluate the portfolio's performance. Okay. And you may need to cluster it apart as not necessarily. It all depends in some ways how deep your original analysis was. Okay. Objectives. Okay. What I'm expecting. Oh yes, I have to do this one too. There's the objectives. Okay. Objectives are as follows. I'll take this one down. I'll go into view. Identify the best securities to go into the portfolio, right? By clearly stating the selection process for each security. Rigor, rationale, and insight will count. So there's not just rigor and rationale anymore. I want insight. Okay, that's the challenge for the project, right? Because otherwise, right, it's just a mechanical exercise. I don't want you to just do mechanics. I've given homework assignments that I've just done mechanics. I've given a couple of lectures where I've just done mechanics. So I want you to be insightful. Okay. Evaluating the assembled portfolio using performance evaluation tools, right? State clearly not just what the results of the analysis are, but which performance tools were used and why. Why did you use them? Right. What was the rationale behind doing it? And what insight did it give you? Okay, that's what the insight is. Okay, the parameters. Meaning basically what you're pretty much going to be seeing, and then what you'll be doing. Okay. You will get via email an Excel spreadsheet with that name. You'll get it on Wednesday, probably Wednesday morning. The spreadsheet will have the following information. All of the ETFs, right? Everything is in percent, right? It's not percent format. I simply multiply things by 100. You have market returns, proxy by the ETFs. You'll have Fama French factors, and if you need the risk-free rate, use the risk-free rate that's in the Fama French data. Okay. Just to make it common all the way across. What else needs to be done? Oh yes, and then there are benchmarks. Those are also there as you saw. Okay. Now comes the actual reviews. Once you've set up the data page, now you set up that data page, otherwise this whole thing is going to take choose at least 5 securities out of the 10, at least 5. Okay? say why you chose these securities. For example, you want a completely diversified portfolio. Now, keep on asking yourself, how do you know a portfolio is completely diversified? It's going to be key, right? Just don't think, oh, yeah, I would do something. It's how diversified. Yeah. And say why you chose certain securities and things of that sort. Construct the portfolio using an equally weighted scheme. Okay? That's needed. If you chose 5 securities, then everyone gets 20%, so on and so on. It's a very simple one. Next project, I will give you a list of 5 ways of putting the portfolios together, and you can choose it for yourself. Okay. Once you have chosen the securities, tell me which ones you have chosen, and I will send you the next 35 months of returns. Why am I choosing 35 months? Because for good statistical purposes, okay, 35, 36 months is good enough to be able to trust the statistics that are going to get churned out, p-values, r-squareds, and things like that. Okay. Use the performance measures, okay? And others, if you like, if you want to do the SML, I'll certainly send you the values for it, the inputs. Analyze the performance over the return period, okay? Not over the whole period, but over the return period, the successive 35 months, right? Again, tell me why you chose what you did to analyze the portfolio, what it said to you, and what insights it did. Okay. I mean, maybe you want to go back and say, I thought, right, this fits like that. I thought this security with a higher Sharpe ratio, right, would have contributed more to the portfolio than it did not. And maybe you can tell me why it didn't. That would be fantastic. Okay. Well, let's go down some more. Okay, what is due to me? The reason why you selected the securities in number 2 above, and B, why you used the performance measures you did in number 5 to analyze the results and your performance analysis as well. Okay. Please write your security analysis and recommendation in a Word doc. I only want to see the whys and wherefores for the securities chosen. I don't particularly care about why you rejected them. I don't care about that. The whole thing is, why did you choose them? What was not so much why was the issue really one of, great Sharpes, so that's why I want it. Why did you want great Sharpes? What was the rationale there? What were you hoping to gain by doing that? What were you hoping to gain if it's going to be fully diversified or something of that sort? Or you want to follow French too, okay? Put everything, right, into a Word doc, only post it once you're